Hello, Alk here again. So last time we left, we implemented this basic UI and just drawing a line, which I realized I didn't really explain how I do it exactly. Let me just quickly do that. Uh, okay, here. So first we set the first points and the last points, like from the start to end. Oops. And basically, it's just selecting a center. Let's say we have a first point and a last point. Basically, the line we select would be like this, and it would have a center point, like around here, and we just uh, use these points as the end points in like creating the object. Let me just make that with a rectangle. The how Cocos renders this isn't exactly this, because there are these endpoints, like as you can see, the black endpoints like are still visible, kind of, which is because like uh, Cocos does this by this throw segment does this by like line width. Basically, it extends from here as a square, from here as a square. Like it places squares everywhere, as kind of like that, which means that we need to like extend the object we create in order to fill these endpoints here. How I do that is actually like not simple in geometry, but not that simple. I get the normalized vector of this slope, which is something like this. Yeah, like if we say this is length of 1, and I for both of the endpoints I multiply this by the like half of the line width. Let me show that code. Basically, this gets the angle, and I rotate it by this angle, this is the center point, like the origin, and this is the line we are rotating, which is the line width divided by 2. Like for example, not that, but this line rotate. Let me show you. This line rotates to like something like this, but it is not this thin, but assume this was like thick, which does fill those endpoints. That's basically what that endpoint extension does. It does offset like the first point by and it subtracts the first point, and it adds to the last point, and it just creates the object, sets the rotation, and scales it based on like the distance divided by 30, because the geometry dash objects are like 30 by 30, like the one grid size. That 30 comes from that line width, also divide by 30. And this is how you update the scale of an object. Custom scale X, custom scale Y. Set scale doesn't really work for game objects. And these updated color, if it has a base color sprite, this is a class pointer. It updates the color to white color ID, which is this 1011, and it's same for detail color. This is mainly would be useful if I had used a different object instead of like the square object, which I think only uses the detail color. But yeah, this is basically how the line thrower works. And today we're gonna implement the curve, which is gonna be pretty hard. Like not like hard as in math, even though most of the things I will copy from other places. Like even in my drawing utilities, I did copy it from this anti-grain geometry project. I will explain that too in just a moment. Like, but it even has more than the what I'm copying, because I will talk about those when I come to this. Let me talk about this anti-grain geometry project at first. It's basically an uh, vector 2D vector graphics library, which does and it's pretty big for what I need. I just need the bezier curves section of it, which there isn't documentation about how what I exactly needed. So since let's talk about the problem at hand first. So we're trying to draw a curve using geometry dash objects. Like a single object is a single line, which means like we need, if we want to uh, use less objects, it would be better in terms of lag and other stuff. So like the less it is, the better. But since we have less objects, the detail will also decrease. So like there needs to be a fine point between those two, and uh, this helps with that. Basically, if the bezier curve, if you don't know about bezier curves, I don't know how to exactly explain. Let me try it. Uh, it's basically a interpolation of interpolations for quadratic. No, for yeah, quadratic and interpolations of interpolations of interpolations for cubic. Let's say we're gonna make a bezier curve from these points. We first draw lines from these two, and basically we linear interpolate from the beginnings of these lines, and like for example draw another line from this. And select like wherever we started from, and we basically continue this for until we reach the end. For example, let's say select another point, for example here and here kind of, and we draw a line from here, and then we do the same linear interpolation between those two, something like here. And yeah, I think those are cubic, but I hope you kind of get the point, even if you don't know the bezier curves. Like it throws something like this basically from these 3 points. And the quadratic bezier, cubic bezier curves are also similar, but instead of 3 points, we have 4 points. It's basically that. So if we as we did here, it's like selected points. It's about selecting these points. Like if we select these points incrementally, this happens. We have these small. No, it goes like normal, but in for example, cusp or like a sharp turn, we use a lot of points, even though we should really not use a lot of points there. Basically, yeah, I will link this document, kind of blog, in the video description. But yeah, it basically explains the problem we have. And yeah, like an adaptive step, for example, in these sharp turns, it does do bigger steps so that it saves on lines for us, and dives on a lot of maths that even I don't understand that much. But it's basic, some kind of derivative, it kind of following the gradient kind of thing. It, when there are sharp changes, it tries to use less points, so that's yeah, I really can't explain because I don't even know that much. I mean, it works. It's kind of magic. But yeah, that's basically what I'm gonna use, and what I used in the previous implementation as well, I had to edit some stuff. For example, for the uh, details, there are still more things to handle after this, but I'll talk about those when we can come to that. I don't think I will directly copy from this because the version 2.5 was licensed under GPL, and uh, 2.6, which is what I'm going to use right now, which is dual license, either modified BSL license and integrated GPL. Okay, so basically it's not GPL. That's the main thing. So uh, yeah, I'll try with the initial implementation, and I'll probably come back to you about like what I implemented and that thing. Okay, so here's a progress update before I actually copy the parts from the library I want to copy. I basically implemented the curve brush drawer, which is pretty similar to line brush drawer, which doesn't have any like update line functionality, just throws an overlay. Apparently, RobTop added these cubic bezier functions in 2.2 to CC draw node, but uh, I'm not gonna lie, I've actually tested them and they do not really work. Probably I'm doing something wrong, but like it just draws a triangle. Let me just show that, like here. Like this is not a Bezier curve. Yeah, I will probably draw my own Bezier curve using the lines. Probably, maybe I'll see. Or maybe I'm just saying something wrong about this, but yeah, the curve, the thing itself, the lines work. Like it's a Bezier curve, like drawer. Yeah, that's it. Okay, I did copy the library, the basically the bare minimum, just the AGG curves source, which uses these, and I just add the simple CMake list for my own repo and copy the readme. And for the, I still haven't implemented any update line thing, but I did add it to overlay, uh, which will allow me to showcase the issue at hand. Uh, this is basically the, yeah, how the AGG curve thing works. It's basically a generator, and you get the vertices from the. It's kind of like a C interface instead of a C++, but it still works. So I'm not complaining that much. I'm not sure. Oops. I'm not sure if it will be that noticeable with the current detail amounts. Yeah, this is like it's basically a cubic Bezier curve. Oops. I realized I forgot to switch up the. Okay, I'll do that. It, basically, the point should like the second point should jump to here for next one. Instead, it stays. Yeah, that's getting fixed. But let me see if I can like show it. Oh, right, it deletes that. Okay. Uh, I don't know if you can see it, but like, uh, especially at the cusps, like there is some kind of spikiness, let's say. Uh, it would be much more detailed if the line width was like much bigger. Let's say, for example, 20. That should make it a lot more noticeable. Yeah, like can you see these big lines? Yeah, that's basically the issue at hand. Like, uh, let me also draw like a thin line on top of this to visualize the problem itself. So yeah, I just added a second line, which is much more thinner than the previous one. It's not that thin right now. Maybe I should make it a bit more thinner, but it will be enough to showcase the issue. Yeah, like when we have a thin line, there is no issue, but when it gets thicker, we see like a lot of spikiness. That's the main issue I had to solve after like finding this. Okay, so let me talk about the issue first. Basically, uh, the draw segment is like with the big line width. It does like draw a big rectangle kind of thing, like encompassing both of those. For example, it's kind of like this, and for example, let's have it the same for this one, and uh, it's the issue is basically here. Like you can also see the spikiness here as well. Yeah, like here or here. That's basically the current issue with this. We can like do the opposite with it and the line drawing, which is the shrink the endpoints to like so that they exactly match. But that also brings its own problems, which I had to deal with first in the 2.1 implementation. Like, let me shrink those. Yeah, basically now there are gaps instead of like having like for example here or here. Now there instead of spikiness there are some gaps, which is pretty fun. Like not fun, but like pretty interesting in my opinion. Let me explain that in a different drawing. Okay, so let's say uh, let's say we have two rectangles. Now the endpoints of both of these, let's assume we actually did shrink these and like the endpoints match. Now here we're trying to like uh, close that gap here, which is basically first we find which side of the two rectangles that have the gap, left side or right side. We can easily say this while when we look at this, but it's not that simple when you consider that these are just points because geometry in programming is not that simple. Okay, so this this uh, when we like consider this angle, yeah, this angle, it's smaller than 180 degrees, which means that it's pointing the right way, which also means left part has a gap. So you find that gap from there, but how to extend it is a bit more convoluted. It's basically you like uh, draw two lines from like that are parallel to the rectangle itself. Uh, yeah, like and find its intersection point, which is that place here. This is the point we are interested in, and from this point we draw two parallel lines, one for each of the rectangles. This one, and then the other one, and we basically extend these rectangles from that point on. Yeah. For example, the lower rectangle would be extended from this way, and the other one would be extended from like this place. And this is so convoluted to do in like programming. Uh, I I had a, like intersection. Yeah, I had a lot of code for this. I'm gonna try to copy if I can. So I probably just re-implement kind of. I'm not that sure, but yeah, we'll see. But yeah, basically that's after we shrink the endpoints, like the opposite of what we did in line curve. The main issue is basically this part. So yeah, I think I'll shrink them first and come back to you. Okay, so I did implement that like reverse shrinking and like replace the line width with for example 20 for now. Like since the rectangle can be smaller since we're shrinking itself and we can't exactly draw it using a draw segment, and we need to draw it using like a rectangle, a polygon itself. So I do that instead, like have four corners of the rectangle, which is basically just angle plus pi over 2 and angle minus pi over 2, which just, yeah, finds the upper and lower corner. For example, when it's here, it just gets like here and here. Oops, here and here. That's basically it for that. Wait, not this. Okay. Let me just show that. Yeah, you can also see those like gaps I talked about, like here, or like on the other side as well. Yeah, that those gaps are basically what we have talked about in here, and yeah, I'm gonna first fix the this opposite changing issue, and I'll come back after I fix that. I did also fix that now. Now it actually should be like changed. Yeah, I'll probably convert it to show all of the uh, lines, and but first I want to actually fix these gaps. Like it's especially obvious when it's like a really big, like a cusp, and so yeah, that's the main issue we have. Okay, so I did the initial implementation by just mainly copying from what I had here, which is here in this curve optimizer. I just had like points, rectangle, circle, plus, and yeah, basically just copied all of them and added also added some comments so that I don't forget what they do again. So that's basically it's right now. I tested it and it crashes on trying to draw the circles. So maybe I should comment that out for now. Uh, Now it crashed somewhere else with a very weird crash report. Yeah, I don't get it. Let me just. Rob's extensions are just weird. Let me just comment that. I'll probably reverse engineer for that, how it works and all. But do the rectangles itself work? Yeah, okay, good. Now, like, actually, this is not a very fair comparison. I should probably increase the line width. Yeah, you saw how like smooth it is. Now there shouldn't be like any of those gaps. Well, in high places there are still some gaps, but because I do have some check for those. No, wait, no, they shouldn't. Those shouldn't have gaps. What did I do wrong? I'm actually not sure. I'll debug this and come back. Actually, not really a progress update, but uh, this is basically what happens when you try to debug math. Uh, yeah, fun things. After some amount of debugging this code, explaining it will take a bit, so I'm gonna do it anyway in a bit. Also, I re-added the circles thingy. That it's basically that like since it tries to extend it, if the rectangles are not that like they are like for example they have really big uh, angle between them. For example, this like extending them would be like pointless because like that would create a sharp edge in which case the it just puts an circle instead. That's where the circles are used in this code. Let me show it here. Yeah, they basically there is no more any uh, gaps. Like even when there's a cusp, like something like this, it uses a uh, I I'm not sure if there's a circle there, but it does use a circle in like specific circumstances. Let me try to yeah, something like that. For example, oops, here. Okay, yeah, here. There's a circle there. Yeah, that's basically it for this. Like curve drawing. The next step will be just putting this into objects, which is not that hard, and also like continuing to draw this. Uh, but yeah, let's try to actually explain this code. Okay, so we get the points list from like this library we use to like create the points that we use it to create the draw the curve. So it for like every pair of points and every three pair of points, we like check the beginning and the end of the rectangle. For example, let me just create a new. This is our start and this is our endpoints, and these are the other 3 points we check for. Like for every like 3 points groups we have, for example, these three or these three. Oops. Uh, we do the like extension checking we did here with this, and see if we can extend this part and fill it. And for the other parts, uh, we do the same if we can extend it from here. And basically, that's the entire code. It first checks if there's an angle. So, like, if points are like on top of each other, there is no angle. So we're just skipping those. And the angle is big enough, which is 135 degrees here. That's basically arbitrary. Like, uh, I want to select the one between, like, if there's two, the angle between them is too big, there will be like this, when we extend, there will be this sharp edge. But if it's too small, we're using like it's too much circle objects, which is kind of undesirable in this context, especially when the angles are small like this. So uh, 135 is kind of a nice balance between those two. And we put this circle here if it's like small enough. Like, yeah, the angle is like, for example, a cusp, which may be a acute angle instead of a like big angle. So how do you extend in computer terms? It's basically the implementation of this. It will fly across your head. Basically, we just get the like perpendicular offsets for both of the like for uh, forward and reverse for both of them. We get this these offsets, this offset for one and this offset for the other one, and B, like, yeah, S1 and S2 are the corners of the first one, and R1 and R2 are the corners of the second rectangle. And we just center point of both of the extensions. Like, we extend both of those, so we return both of those. And the angle implementation is basically checking from 1 to 2 and 3 to 2, like, so that we get the angle here and not the angle here. We don't want the small angle here, but instead the angle between those two. It's basically kind of a preference. So, but yeah, I just swapped two and one, and like in a normal angle calculation, the two and the one would be like swapped here, but instead I did that one to two, and yeah, the intersection is basically the small velocity. Like there are the ABC coefficients of the line equation, and it just intersects both of them. It's just pure math. That's basically how this is implemented. And yeah, you can see even though it's so thick, you can see how smooth it is. And yeah, let me just like uh, add this with like to the GD object as well, and like extend it to make the spline instead of like just a simple fun bezier curve. Yeah, that's it. Okay, so I did implement the update line functionality. I separate the optimizer thing into like in its own function, since I'm using it in both the overlay and the update line itself. It does like just for the rectangles, it creates the square object and scales it appropriately, and the circle, it uses the difference object, which is the 725 object ID, which has a weird scale, but it works. So yeah, I'm not really complaining about that much. And yeah, it's the same for that as well. And I did that current point, previous point implementation as well. And I did that like this. I did that this quickly for like key down and answer and like the current drawer. But I think I will convert that into like custom keybinds instead. And like the and since there is no real way to like stop it by instead of like by pressing enter, for example, when you're doing this on mobile, you probably need to press the button itself for now. But I'll probably add a like secondary button which allows you to like stop and like finalize the curve itself. I'm not actually exactly sure about that. I may add that in a like next update or something. But yeah, let me just show you how this works. So yeah, it's basically like the curve, like even cusps and all work. And yeah, and like when I press enter, it finalizes. And since the current one is a bit detailed, this is like 71 objects, but I probably gonna decrease the detail, which I actually did decrease the detail in the like my previous one. It used like 0.1 instead of 0.4. I think I'm not exactly sure about the values, but let me try to change that value. Okay, so I added the curve like a curve roughness, which will probably be an adjustable value in the, for example, in the next update. It's by default 1.0, but I decreased it to, for example, 0.4, and let's see like how that works instead. Like it will be a bit rougher, but I think it should use less objects. Yeah, now it uses like 53 instead of 71, which is kind of better, since 71 is bigger than 53. Like, and even in edge cases, it doesn't really like fail. Like even in like these, like it works. Like when I come to this endpoint, like cusp, yeah, here's the circle it uses. So like since this is a very big angle, like not big, like very small angle in the inside, so it uses, if we extend it, it would be like very sharp. So it just puts a circle object there. So yeah, it's that's I think this will be it for this video, because like it's already, I think, 30 minutes something, 35 minutes. It's long. It's very, very, very long. Let me try to like draw something, I don't know. It's basically it. So I think I'll like finalize the detail and like write a changelog and all those things, and then probably share this. So yeah, that's it. Goodbye.